Let's start with 12-factor application methodology. Codebase. There is only one code base per app. In microservice architecture, it's only one code base per service, but there can be numerous deploys. The code base must be the same across all deployments, although different versions may be active in each deploy. For this reason, it's essential to track the app in a version control system such as Git. Second, dependencies. Declare all dependencies precisely via a dependency declaration manifest. Use a dependency isolation tool during execution to ensure that no implicit dependencies enter from the surrounding system. This applies to both prod and development. Third, config. You should store all the configuration data separately from the code in the environment variable and not in the code repository. And this should be read in by the code at runtime. A separate configuration file makes it easy to update the config values without touching the actual code base, thereby eliminating the need for redeploying apps when config values are changed. Fourth, backing services. Backing services are usually managed locally by the same systems administrators who deploy the app's runtime. The app may also have services provided and managed by third parties. Treat backing services as attached resources. This ensures that every service is completely portable and loosely coupled to the other resources in the system. 5. Build, release and run. Strictly separate build and run stages. Use a continuous integration or continuous delivery tool to automate builds and support strict separation of build, release and run stages. Docker images make it easy to separate the build and run stages. Images should be created from every commit and treated as deployment artifacts. 6. Processes. Execute the app as one or more stateless processes. Ensuring the app is stateless makes it easy to scale a service horizontally by simply adding more instances of that service. Store any stateful data or data that needs to be shared between instances in a backing service such as database. 7. Port binding. Export services via port binding. The app should be completely self-contained and not rely on the runtime injection of a web server into the execution environment to create a web-facing service. The web app exports HTTP as a service by binding to a port and listening to requests coming in on that port. 8. Concurrency. Scale out via the process model. Supporting concurrency means that different parts of an app can scale up to meet the need at hand. When you develop the app to be concurrent, you can spin up new instances to the cloud effortlessly. 9th, disposability. Maximize robustness with fast startup and graceful shutdown. An app's process should be disposable so they can be started, stopped and redeployed quickly with no loss of data. This facilitates fast, elastic scaling, rapid deployment of code and config changes, and robustness of production deploys. 10th, dev or prod parity. Keep development, staging and production as similar as possible. Continuous deployment requires continuous integration based on matching environments to limit deviation and errors. As such, dev, staging and production should be as similar as possible. Logs. Treat logs as event streams. Stream logs to chosen location rather than dumping them into a log file. You can direct the logs anywhere, for example to a database in NoSQL, to another service, to a file in the repository, to a log indexing and analysis system, or to a database housing system. 12. Admin process. Run admin management tasks as one-off process. The idea here is to separate administrative tasks from the rest of the app to prevent one-off tasks from causing issues with your running apps. Containers make this easy. as you can spin up a container just to run a task and then shut it down.